I'm now going to conclude my discussion of the Bezier curve with this particular video. Alright, now if you will recall from the last video, I helped you determine the length of this particular line. I know that's kind of ugly, but there you go. This line right here, I helped you determine the length of this line right here, and I also said that you could find the midpoint of this line and then you could draw this perpendicular to it. Now what happens here is you have a right angled triangle, and this is going to help us out by determining the length of this particular line. Now, do you remember anything about trigonometry? Well, if you do, let me erase this for just a second. Okay? What we're going to use is we're going to use trigonometry, and this particular angle right here. See this particular one right here? We're going to call it, okay, we'll just put a T there for theta. Okay? Because they usually call angles like this theta. So we're going to say this theta angle. How are we going to use this using trig to find the length of this particular line? I want you to draw this out. I want you to pause this video, draw all of this out, and be ready because I'm going to tell you the answer to this. Okay. Are you ready? Did you draw all this out? Because I have to erase it now to show you this. Good. Alright, let's erase this. Now, as we know, we're going to use the cosine function. Okay? And do you know why? Because that bottom line was the adjacent line to that particular, to angle theta. Okay? Remember I had angle theta, and there was that line, it was adjacent. Okay? Because you had the one line that was a hypotenuse, and then you had the other line which was adjacent. Okay, so what we're going to do is we're going to have A for adjacent. That's the length of the adjacent line. We're going to have H, which is the hypotenuse, which was that great big line I was telling you about. Okay? And it's going to equal the cosine of X. Now you say, well, that's not going to help us out too much. Oh, yes, it is. Because we're going to multiply both sides of this equation by H. This cancels this, and now what you're going to be left with is the length of the adjacent side equaling the cosine of X multiplied by the length of the hypotenuse. Okay? Now, we have to get this cosine of X over here. Once we do that, and we eliminate this, and what we have here is the length of the adjacent side divided by the cosine of X. Now, what is X actually? Okay? Well, we're going to replace that X with the letter T. You remember how that angle was known as theta? Remember I told you that that T represented the angle theta? Okay, so you have the adjacent angle divided by the cosine of the angle theta. And if you do this, you'll get the hypotenuse, which is that other length. And that's how you'll do this. Now you say, well, wait a minute. How do we do all this? Well, you're going to physically draw out your triangle on a piece of paper. That's why you'll get the angle. Okay? You won't have to draw out perfectly the lines. All you have to do is get the angle. Okay? You're not interested in getting all the line lengths when you draw this out physically on a piece of paper. All you're interested in is finding out those angles. Once you got that, you can use this. So when you determine the length of that adjacent line, and you determine the cosine of angle theta, you'll get the hypotenuse. And that's what you want. And that's how you'll draw this in SVG. Okay? Now then, I know the question will arise, well, this is all great and dandy and everything, because that's how you get your y coordinate. But what if your triangle is drawn like this? Well, you'll have an x and y coordinate of this midpoint, okay? And then you'll have this length right here, which is your A, okay? And this is your H, which is your hypotenuse, okay? Once again, we have this 90-degree angle, and this is angle theta, okay? So you'll have all of this, and what you'll do is there'll be a x-coordinate length for this because you're going across the x-coordinate axis and you're going across the y-coordinate axis, and you'll have to determine the length of both of those, and then you'll use the cosine of angle theta to figure out the x and y coordinates of the hypotenuse this end. Okay, you'll have this end, but you won't have this one. And that's how you'll do that. And I think if you put your mind to it, you'll figure this whole thing out. But like I said, what you're going to do is you're going to have A times the cosine no, that's wrong. That's wrong. Sorry. You'll have A over H. Whoops. A over H equaling like that. Again, like I said, you'll move the H over here. You'll multiply this by H. That'll remove these H's. And then you'll divide both of these by the cosine of t. And then when you do, you'll eliminate these two terms. And finally, you'll end up with H. And what you're looking for is the length of this line. And when you know the length of this line, you can determine the x and y coordinate of that line. And that's how you'll do that. Just use a little arithmetic and you'll figure this all out. Alright, now that you know all of this, you can finally create your Bezier curves using SVG. And once you do that, you can draw all kinds of stuff. Now, I want to make sure that you're getting all this. Yep, you are. But you see, it's just not that hard. So, hopefully you will apply all this to all the other lessons I gave to you, and you'll put this into action, and you'll start drawing nice little curves in SVG using the path statement. And I already illustrated this in previous videos. If you go to those HTML videos, you'll see this. I will do another HTML video where I will draw the head of a horse. And when I do, I'm going to use all this. And then I'll show you exactly how it works. Alright. Well, I want to thank you very much for watching this presentation. Let me know what you think in the comments below. I will tell you more in a future video, so I'd like for you to stay tuned.